In this lesson, we will use the OpenStego utility to assess organizational security. So what is OpenStego? OpenStego is a free open-source steganography tool used to hide data within image files. It is used by cybersecurity professionals, researchers, and individuals needing to securely conceal information. It is typically used when sensitive data needs to be hidden or securely transmitted without drawing attention. OpenStego runs on Windows 10 and other operating systems with Java installed. It is used to protect confidential data from unauthorized access by embedding it invisibly within cover files. It uses steganography and optional encryption to embed hidden files within images for covert data transfer. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the description below. Also, if you like this content, please like, share, and subscribe to the channel so you won't miss any new videos. So we have our companion guide on the left, we have Windows 10 virtual machine on the right, so let's get right into it. So as previously stated, OpenStego, or sometimes called steganography, allows us to embed files inside of files. So OpenStego is a free open source tool that we can use to do that. We have two features available in OpenStego. One is data hiding. We're going to take a text file and embed it into an image file, and we can also watermark a file so that way we can say that this is our file. So it allows us to authenticate the origin of a file. So we're going to download a couple of sample files, but first I want to give you a little background onto my setup. So this browser here is on my host operating system, and this Windows 10 is a virtual machine. I have shared folders set up on VirtualBox. So let me just give you a quick look on what that looks like. This is my downloads folder on my host operating system. I happen to be running Mac OS. So this is my downloads folder here. On my Windows virtual machine, I have set up shared folders on VirtualBox. In other words, if I go here, we go to devices, there's shared folders, and there's the shared folder setting. And essentially what I'm doing is I'm allowing this Windows virtual machine to periscope or peer into my host operating system to this file path. So it's users, my username into my downloads folder. So we're going to take a look at it on the Windows side so we can see what that looks like. So when I go to Windows, I open up and I see this PC has a number of drives on it. It has a local drive, it has the VirtualBox guest editions, but it also has this Z drive. This Z drive is the exact same thing that you see here. You see archive, software. So this folder here on the Windows machine is peering or periscoping into my host operating system. The reason why I do that is because I go through virtual machines fairly quickly. I bring them up, I tear them down. Sometimes it's Windows 10, Windows 11, whereas my host operating system is pretty stable. So I download some files here and then I just share them from the Windows virtual machine to set that up. If you want to set that up, click on the link here. It's on the Windows virtual machine setup. So if you go to the lab on Windows 10, it'll walk you through how to go through that process. So this will explain everything for you here on the hands-on labs training for Windows Security plus Windows 10. I'll put that into the show links below. Okay, back to the task at hand. So we're going to download the cover file called the bridge PNG. So that is also linked in the show notes below. So we have this file, it's a cover file, it's a PNG file of the Brooklyn Bridge. I'm going to download that into my downloads folder. We'll give that a second. It asks me where do I want to download it. I'm going to actually put it into the downloads folder. Okay, so we have that there, and I'm going to refresh the Z drive, and I should see this bridge folder was just downloaded here. I'm going to do the same thing with the sample.txt. The sample.txt is a sample text file. It basically has a little bit of text that goes in and tells you this is the first line. It has 100 lines. I want to download that as well. So we'll go ahead and download that into the downloads folder, and I'm just going to accept that as is. And it has accepted it. I know it's on my host operating system, so that's fine. But let's refresh on this side here on the downloads folder here, go back to the Z drive, and I have my sample.txt. So I can open it in Windows. I see that it's a regular text file. This is the file that we're going to embed inside of the bridge file. And the bridge file is a regular PNG file that's going to be the picture of the Brooklyn Bridge. So that's what we're doing here. So we have the Brooklyn Bridge, we have this text file, we're going to embed that into this image. So we're all set. Now, a couple of things, as we mentioned before, is that anytime we download something from the internet, especially if they have hash values, we want to compare those hash values. So we're going to use PowerShell to do that. So I can close out these images of these files. I don't need them just yet. I'm going to keep this Windows Explorer here, and in the search bar, I'm just going to type PowerShell. So if you type power, it'll be one of the first things that come up. So I want Windows PowerShell, and this is like being in the command line editor in Linux. I'm going to resize it to give us a little bit of room so we can see both at the same time. So I have my Windows Explorer, I have PowerShell enabled here, and let's just get this organized. Okay, so I have PowerShell here on the Windows 10. I also have Windows Explorer looking into the Z drive, which is where we have our files stored. So in order to get to the Z drive, it's like any other drive. I can just type Z:, and now I'm in the Z drive. And if I do a directory listing, I can still see the same folders. However, we're at the command line. So I see my archives, software folder, and system volume. But more importantly, I see my bridge file, and I see a couple of sample files here that we will use for this tutorial and also other tutorials going forward, like Windows hexadecimal or WinHex. Okay, so for now, what we want to do here is I want to get the hash value of the bridge.png file, and we want to make sure. So I'm going to clear the screen so we can see that. I'm going to use the get file hash, and I can just tab complete that. I'm going to do minus uppercase A, L to get algorithm. We're going to use MD5. This is an MD5 hash, and I'm just going to type bridge, and it's going to put the dot backslash for me. And when I hit enter, it's going to give me the hash value of the file. So my file is starting off with Delta 036 Echo 4, Delta 036 Echo 4, Bravo Alpha Echo, Bravo Alpha Exo. I can continue this, but I know that this is the hash of the cover file, so we're looking pretty good here. Let's do the same thing for the sample text file. I want to take a look at the sample text document that we downloaded. So in this case here, I can just up arrow. I can back up to this portion here. I'll do sample.txt, and I see its hash value. So it's E62549, Echo 62549, Charlie Alpha. I see that this matches. That's good enough for now. We can continue this process, but for tutorial purposes, we want to make sure that we are checking the hash values. This tells us at least two things. Number one, when we downloaded the file from the internet, it wasn't corrupted during the file transfer process. And number two, the integrity. The file is exactly as it was intended. In other words, there wasn't an adversary in the middle who tampered with the file. So we look pretty good here. Let's go ahead and make a copy of the bridge file. So I'm going to copy the bridge file, and I'm going to make another file called hidden.png. And we want to do this for a couple of reasons. Now, if I reset this here down here, I can do a directory listing here, and I see my hidden file. It's exactly the same. And I can refresh. I can do this a couple of ways. I'm just going to do the easy way. I have a bridge file and a hidden file. They are both the same size. So it's 4.1 kilobytes, 4.1 kilobytes. They're exactly the same. And the point that we want to make here is that when I make a copy of a file, it should have the same hash. So let's go ahead and build this value out together. So I'm going to do an open parentheses here. I'm going to do get file hash, and we'll build this out together. And we're going to look for the bridge file. So I want the bridge file, and this time I'm going to just call the -a. Same thing for the algorithm, and it's MD5. And it doesn't have to be case sensitive .hash. And I want to see if it equals, to see if it's the same thing. So I'm going to dash EQ, and I'm going to do the same thing here. Another open paren. I'm going to do get file hash, and this time it's going to be the hidden file. And we want to see if it compares. I'm going to do -A for the algorithm, MD5, and close out the paren or parentheses, and then .hash. And I get true. In other words, the hash value of these two files are exactly the same. So now we know those two files are exactly the same size, and they produce the same hash. I could have done them individually, but we just wanted to show you another command and also introduce PowerShell. It's probably the first time we've seen PowerShell in this series. So we'll close out some of our housekeeping. And now we're going to actually get into the OpenStego. So let me bring this up here. I'm going to minimize. I'll clear the screen a little bit so we can have a fresh listing. We don't want dirt, we want dir or ls. So I can do ls here just like in in Linux. So we can do ls, same thing. I'm going to minimize the command line and also the Windows Explorer. And let's go ahead on the Windows 10 computer. We're going to launch a browser, and I'm going to actually go to Java and download the Java supported section here. So Java is required for OpenStego. So we're going to just go ahead and visit this URL, and I'm going to do that on the Chrome side, and it's going to take me to the download Java page. So I'm going to download Java for desktops and follow the on-screen instructions. When I download it, it'll take it to my local, i.e. my Windows downloads folder, because that's how it's configured. I had it set up before, but this is what the Java looks like. And I'm going to run and set it up. So I'm going to double click that and actually follow the on-screen instructions. It's going to initiate the user account control just to make sure that there's a human behind it and we actually want to do this. It's not some kind of errant script. I'm going to close out the downloads folder for some housekeeping, and I'm going to let Windows do its work. Now, just to be sure, sometimes you may want to minimize the Chrome browser to make sure there isn't anything happening, and we get this dialog box. At this point here, we're going to accept all of the defaults. I'll click install, and we'll allow this to install on its own. Okay, so that took about 13 to 15 seconds. Mileage may vary depending on your computer, but this is what we're looking for. It says we have successfully installed Java. So we can close this out, go back to our housekeeping. We have Windows 10. We also downloaded Java. Now we have to go to OpenStego. So I'm going to go back to our browser. I'm going to copy this here. You can type it if you want. And we're going to go directly into OpenStego. So I'm just going to do this in a new tab and go directly to the URL of OpenStego. And here it is. It gives us the page, and this is what the interface looks like. So in order to download this, we're going to go to the downloads portion of the page, and it's going to automatically download the Windows version of OpenStego. And I'm going to, well, in this case here, it took me to the downloads page. What I'm looking for is the .exe, the executable. So I'm going to set up OpenStego 8.6. I click on it, and then it starts to download it for me. And it says it is already downloaded. So I'm going to go into the downloads folder. And here's my setup OpenStego 8.6. I have a couple of instances already because prepping for the video, wanted to make sure everything was fine. So I'll close this out. I'll actually minimize this so we only can focus on the OpenStego. And I'm going to accept the end user license agreement. Click on next and click on install to continue. And I'm going to wait for this to work, and it says it's completing. I clicked finish, and that's it. That was pretty straightforward and fairly quick. So we're downloaded and installed OpenStego. Let's go ahead and hide some data inside of data, the moment of truth. So now we're going to go into OpenStego. So I'm going to do OpenStego, short for Open Steganography. And here's the app. So I open the app, give it some time to stabilize, and here it is. So I have two instances of it because I probably double clicked. I'll bring this over here so it can be a little bit closer to the companion guide, and we'll go ahead and work with it at this size here. So we have OpenStego. We have two tabs, data hiding and watermarking. Let's do the data hiding. So this is where we're going to hide data in data. So we're going to look for a message file. This is where we're going to place that text file that we talked about into a cover file, the photo. So our text file is going to be this simple text file. And I'll just open that up again. This is a simple text file. And this is a message that we're trying to send to someone, but we don't want anyone to know. This is how you can bypass a data loss prevention system, where if they're looking for a particular type of data, they being the cybersecurity professionals, you can embed your secret data inside a harmless looking photo and put it in there. Now, once again, this is for training purposes, and we'll show you how to detect that in a moment. So here's my message file. My message file is going to be in this PC. And remember, I'm keeping everything on the Z drive, and I'm looking for a sample file, sample.txt. My cover file is going to be the bridge file, the photo of the bridge. And I'm going to create a new file, and this file is going to be the copy of the hidden file that we talked about. So this is the hidden file that we have created here. Now, if we want to, we can put a password on this. I'm not going to use a password because for speed, expediency, and for training purposes, but we are going to use encryption. We're going to use AES 128. You can use AES 256. As you know, this is symmetric encryption. This is make sure that it is scrambled, that the data is scrambled. So we have our message file, we have our cover file, we have our output Stego file. Now we're going to hide the data. It says it already exists because we made a copy of it, and that's fine. I wanted to make a point, and we're going to say yes. Okay, so it gives you a confirmation. It says message embedded into one cover file. It didn't skip any 0 files, so fantastic. So now let's do a couple of things here. When we first started, if you notice, the bridge file and the hidden file were exactly the same. Now when I come back into this, I'm going to refresh, go back to the Z drive. The hidden file is a little bit bigger now because we have embedded the text file. They both look exactly the same. So let's go ahead and launch both. I'm going to launch the original bridge file or the bridge PNG. And I'm also going to launch the hidden file. So once again, both look exactly the same. They're barely noticeable to the human eye, but inside the hidden image that no one can see is this text file. Now, the way that we would know about this is that if we were running PowerShell and we had, let's say, a file integrity monitor where we can check hash values, we know what the hash values of the bridge and the hidden file is before. Now when we run the comparison, we get a false. So that's one way you can potentially detect if you have files that were tampered with or changed, or if they have deviated from the original file. And you can set something up like that with Tripwire, which we can do in a future course. So that's one part of this that's done. So let's minimize this, get this out of the way, the hidden file, the bridge file. Now, if this was truly a covert operation, we would take this hidden file and we would email it, transfer it, put it on a thumb drive, send it to someone else that would know that we were working in this process. This would be spy versus spy type of thing. And the spy would go ahead and now extract the data. Now they would do the reverse process of this. Let's see what that looks like. So I'm going to close the hidden image. We don't need the Windows Explorer anymore. And now we're going to extract the data. So now I'm switching hats now. I'm on the other side, which is I'm the recipient. We are in collusion working together. I go to extract data. I'm going to input the Stego file. This is the hidden image. that has the text file in it. We have an output folder. I'm going to put it right to the desktop. Give this a little bit of room so we can see it. And if we had a password on the file, we could have, but I elected not to do that. I'm going to extract the data. Give it a moment. It says a file has been extracted. And this is the file that's been extracted. And this is how you can get certain types of files past a data loss prevention system that's looking for particular files, but if they're embedded in additional files, you can evade detection that way. The flip side is that if we know the hash values of particular files beforehand, we can do some comparison, and later on we can actually look at files using WinHacks to take a look at some of the steganography files that are embedded in other files. Okay, so we did the hidden. So we saw how we can use the message file, the cover file to create the covert or stego file. We didn't go with the password. We hid data and we had our file. We did also the reverse, which is we went to extract data. We took the stego file. We outputted it to the desktop folder. We didn't use a password. We extracted the data and now we see the original file. Now, steganography is not just used for subversion or trying to evade detection. You can actually put legitimate files or watermarking into files. For example, as some of you have known, and thank you who have purchased the ebook, I need to put some copyright protection on that so that way if anyone was to use that book and say it was their own, I could prove that this was my original work and I am the original author of that. So we're going to take a look at watermarking for copyright protection, content authentication, or tracking and tracing. So let's go ahead and see what that looks like. So let's go back to OpenStego. So I'm going to, we don't want WinHacks just yet. That'll be the next lesson. Let's go to OpenStego again. And this time we're going to put some copyright protection onto a file. So we're back here and we're going to this tab here is digital watermarking. It's marked as beta, but it does work fairly well. So I think it's reliable enough for us to use it or at least go through the concepts. So we're in the watermarking tab. First, we're going to create a signature. So we need to create a digital signature. Now you need a passphrase to create the signature to make sure that when you're going through the authentication process or authenticating the original work, that you can produce a secure signature file. So I'm going to say, here's the Open Sesame is going to be the passphrase or the password for the signature file. Now we're going to create a signature file and I'm going to put it onto the Z drive. And I'm going to call it at Cyberlabs. So at Cyberlabs 007. This is going to be my signature. This is what I'm going to use to, and it has a .sig, to authenticate or to make sure that I can validate an original work from a copyright perspective. So I'm going to generate this signature and it says the signature was created and I'm going to take its word, but we live in a trust but verify environment. Let's make sure that it's actually there. So I'm going back to the Z drive and I'm looking and I see my Cyberlabs 007.sig signature file. Okay, now I'm going to embed the watermark inside one of our files. I'm going back to embed watermark, and this is the file that's going to have this embedded watermark that no one can see. It's invisible to the naked eye. So I'm going to back to my bridge file. It's my original file. I'm going to use my signature file here to encrypt it and put in the watermark. And the output file is going to be, I'm going to call it bridge, and I'm going to append it for DRM, Digital Rights Management. I click open. So just to recap, this is my file that doesn't have the watermark. I have a signature file that's going to embed encryption into the original work, the bridge, which is watermarking it. And we're going to call this the digital rights version. And this is what we would post onto the internet and we can now embed this watermark. And now we have a way of verifying that this is truly our original work. And you see this in a lot of PDFs or music files that are trying to track and trace documents. They can do content authentication, as I mentioned, and you can do copyright protection. And let's go ahead and see what that would look like on the reverse side. So let's say there was a copyright dispute and someone says, well, how could you prove that this was your work? Well, I would say my work was found on XYZ website and I can prove that this is my work. So I would go ahead and this is verify the watermark. So this is where we are here, verifying the watermark. So I would go to the file that's in question. It's the Bridge Digital Rights Management version of it. And I'm the only one who has this signature file. I go ahead, I get this signature file, and I verify the watermark. And the watermark should come back with 100% strength. That means it is mine. And this is how we can do watermarking for copyright protection or digital rights management. So there you have it. We went through OpenStego to show steganography both from a hiding data and extracting data perspective. We also used it as digital watermarking, the beta version, but good enough for class purposes. Last but not least, if you want a little bit more information about OpenStego, you can go to their website. What is steganography? It tells you about digital watermarking. The link is in the guide here. And as with all the tools that we have gone through with class, this serves as a high-level introduction. I highly recommend that you play with these tools once, twice, 3 times. As the saying goes in class, smooth seas do not make good sailors, which is to say that we want to have some challenges and some trouble with our lab so that way we can work through the challenges and get better on the other side. Speaking about the other side, the next class is going to be on Windows Hex Examiner or WinHex, where we can continue this conversation. But for this time, we're all set with steganography. I hope you enjoyed this quick lesson, and I'll see you at the next one.